In this lesson, you will learn to simplify rational algebraic expressions. Now, when we say rational, what we mean is a fraction. So what we're doing is we're going to simplify fractions in this lesson. And we're going to begin with a little bit of review because we're going to build up to some more difficult problems by the end of this lesson. So here at the beginning is a little review. And here we have something we've seen in a previous lesson where what you want to do is, since you're dividing, you can take the x's and divide those together, and the y's, you can divide those. So when you divide x squared over x, what you have is you can subtract the exponent, so 2 and a 1, which gives me x to the first power. And that's going to stay in the numerator because the 2 is bigger, and that was in the numerator at the beginning. And now we have the y's, and so y squared over y to the third. Here's a 2, here's a 3. We subtract the exponents, and 2 minus 3, we get a negative 1. If you do 3 minus 2, we get a positive 1. Either way, we get y to the first power, and the exponent is bigger down here in the bottom, so my solution would be down in the bottom as well. And the 6 just stays up here by itself. So what we have is 6x over y as my solution. Let's do one more example. Here we have 6x squared y to the third over 3x y squared. Well, we could take the 6 and the 3 and divide those. We get 2 over 1. X squared divided by x. We subtract the exponents, 2 minus 1, to get the first power. So we have x to the first power, which goes in the numerator because the bigger exponent started up here in the numerator as well. And then y to the third over y squared can reduce. I can subtract the exponents, 3 minus 2, to get 1. So I get y to the first power, and it stays in the numerator because the exponent 3 was in the numerator and is bigger than the 2. So now our solution would be 2 times x times y, which would be our solution. So now from here, we're going to increase the difficulty, where now we have not just monomials, but we have maybe something along these lines. But the concept is still the same, where I can cancel things that are in common. So notice down in the denominator, x minus 2, we can think of this as one quantity. And in the numerator, we also have an x minus 2. So what we can do is we can cancel the x minus 2 in the numerator with the x minus 2 in the denominator. So my solution would be x times x plus 4. Now we have x times x minus 2 over x. Same concept. There's an x in the numerator, x in the denominator. We can cancel, and we're left with just an x minus 2. Next example, we have x over x times x minus 2 times x plus 4. Notice there's an x in the numerator, x in the denominator. We can cancel. Now we are left with a 1 in the top, and x minus 2 times x plus 4 in the denominator. Now one more along these lines. Here we have x times x minus 2 over x. Notice numerator has an x, denominator has an x. We can divide, and we're left with x minus 2. Now, the last several examples, this concept only works if everything is being multiplied together. So here we have x times x minus 2 over x. So yes, there's a minus sign here, but we have x times this whole quantity. So we are multiplying everything in the numerator, and then the denominator just has the x in this case. But if everything is multiplied, then we can cancel like we've been doing the last several examples. So in an example like this, we cannot cancel right away because everything is not being multiplied. Okay, we need to factor at the beginning. And that is one key reason, one key application of factoring, is so that we can simplify fractions. Now here, notice the numerator, x squared minus x. Both terms have an x in common. So what I can do is I can pull out an x. So I pull out an x and I'm left with something in parentheses. So in parentheses, I ask myself, x times what would give me the x squared? And that's going to be just an x. x times x gives me x squared. And then I ask myself, x times what would give me a negative x? Well, if I have a negative 1 right here, x times negative 1 would give me the negative x. And then the denominator stays the same with x minus 1. So now notice x minus 1, this is one quantity, and what I can do is I can divide this x minus 1 by this x minus 1. So my solution would now just be an x. So once again, make sure that you factor first before you start dividing things out. We need to have everything be multiplied and divided together. And the denominator, this is just one quantity down in the bottom. Here's another example where we need to factor first before we start canceling things out. And here, the numerator, notice with each of these terms, they have a 3 and a t to the third in common. The GCF would be a 3 t to the third. So then in parentheses, I'm left with something. So 3t to the third times something gives me 3t to the fourth power. Well, if I multiply by a t, I get the t to the fourth. And then the second term, 3t to the third times what would give me negative 12t cubed. Well, 3 times a negative 4 would give me the negative 12. And then we already have t to the third here and here. So that would be it for that second term. So I can factor the numerator to look like that. The denominator would stay the same. So now from here, I can simplify. 3 divided by 6, I have now 1 over 2. T cubed over t squared, I can simplify, and I can subtract the exponents, 3 minus 2, to get t to the first power. And I'm left with t minus 4 in the numerator. So my solution would be t times t minus 4 over 2. Now with ones like this, there is a shortcut we can use. So we can factor, as we just did. But a shortcut is we can divide right from here, right from this first part, where I can see that every term has a 3 in common. So what I can do is I can divide 3 and the 6 to get 1 over 2. But don't forget, I also need to divide this 12 by a 3. And that is where many people make mistakes. Many people will see the 3 and the 6 and just divide to get 1 over 2, but then totally ignore the 12. So I can only divide if I'm dividing every part, every term like this. And this only works, by the way, if there's only one term in the bottom. So if it's a monomial down here in the denominator, then that's the only time this is going to work. Okay, in the t squared, I see that every term has a t squared in common, so I can divide this by a t squared to get that to cancel. T to the fourth divided by t squared, I'm left with 2 t's. And then t to the third divided by t squared, I'm left with t to the first power. So what I have would be a t squared minus 4t over 2. T squared minus 4t over 2. And notice that is the same thing that we have here. We have t squared minus 4t over 2. So either way you want to do it is fine, as long as you are careful with that second method. But it's probably best practice to get in the habit of pulling out the greatest common factor, but either would work in this scenario. Now here's a scenario where I cannot do what I just did, okay? Because here there's multiple terms down in the denominator. So what I want to do is I need to factor the numerator and denominator both before I can start canceling things out. So looking at the numerator, I see that they both have a z squared in common. So I can pull a z squared out for the numerator, and then in parentheses I'm left with something. So z squared times what would give me z to the fourth power? Well, that's going to be a z squared. Z squared times z squared would give me z to the fourth. And then z squared times what would give me a negative 4z squared. And that's going to be a negative 4. Z squared times negative 4 would give you negative 4z squared. Okay, and actually, I can keep going because notice the z squared minus 4 is a difference of squares. The z squared minus 4 I can write as z minus 2 times z plus 2. So make sure you know how to factor because that's going to be very important in this lesson. So the numerator can be reduced or factored down to that, z times z minus 2 times z plus 2. And then the denominator, you have z squared minus 4z plus 4. It's a quadratic trinomial, so I can factor like this, where I know that it's going to be z times z to get z squared. 4 can be a product of 1 times 4 or 2 times 2. Okay, but, or it could be, I guess, negative 1, negative 4, negative 2, negative 2, because 2 negatives would give you a positive. Well, which one would add together to give me a negative 4z? Well, that's going to be right here, negative 2 and negative 2, because when I add, I get negative 4z. So the negative 2's will go here, so my factored form would be as you see right here. So now we can simplify. We see z minus 2 in the numerator, z minus 2 in the denominator. I can cancel those, so my final solution would be z times z plus 2 over z minus 2. And that would be the simplified form of the original expression. I have 2 more examples I'm going to walk you through. This next example, we begin by looking at the negative exponent. So here, we want to get rid of the negative exponent. And to do that, remember, we can write that as 1 over. So what I can do is I can write this as 1 over. So I can bring this down to the denominator. So now I'm going to have r squared minus rs on the numerator, and the denominator would have the r squared minus s squared. So I've done that, and then from here, to cancel things, I need to factor first. So looking at the numerator, notice that they both have an r in common, so I can pull an r out. I'm left with, in parentheses, an r minus s, because r times r gives me r squared. R times negative s would give you the negative rs. And the denominator is a difference of squares, where I have an r squared and an s squared. So when I factor, it's going to be r minus s times r plus s. That is how I factor a difference of squares. And then from there, r minus s cancels with r minus s, and my solution would be r over r plus s. And that was it. By the way, the temptation would be to see the r's and try to divide, but I cannot do that. That does not follow the laws of fractions. So my solution would simply be r over r plus s. And now for the last example. This one is kind of a tricky one, but if you notice that the numerator and denominator are almost identical, with the exception of the sign. So the numerator, we have a positive 2. The denominator, we have a negative 2. The numerator, we have a negative x, and the denominator, we have a positive x. So a technique I can use is similar to one you've seen before, but I can pull a negative out of the numerator, where if I pull a negative out, and then in parentheses I'm left with something, what I'm left with is going to be the opposite signs of what I started with. So instead of a positive 2, I now have a negative 2, and instead of a negative x, I have a positive x. So I can double check by multiplying back through. Negative times a negative 2 would give me a positive 2. The negative 1 times a positive x would give you a negative x. And then your denominator would stay the same. But notice the numerator, instead of negative 2 plus x, I could write that as x minus 2. And then the denominator stays the same as well. So notice what I have. I have the numerator with x minus 2, the denominator with an x minus 2. I can cancel those. And I'm left with a 1 over 1. So it's a negative 1 over 1, which would just be a negative 1. So that would be my solution in this case. And that concludes our lesson for today. So we will see you next time.